Running organic reactions often requires specialized equipment and glassware. This video gives an overview of the most common types. Most reaction setups begin with a support stand. For larger setups, a second stand might be used. Ring clamps, or three-pronged clamps, are attached to the support stand with clamp holders. The best way to attach a clamp to a clamp holder rests the weight of the clamp on the thickest part of the holder and faces the clamp away from the screw. This clamp is mounted towards the screw and may be difficult to adjust. Organic reactions are often run in round bottom flasks. Make sure to set these in cork rings so they don't fall over. This rubber filter ring can also work. Many pieces of glassware include ground glass joints. These joints help glassware fit together and create an airtight seal. If heat is used, a small amount of grease may be added. Glass joints should also be held together with a plastic clamp. Notice the wider piece of the clamp is attached to the wider part of the glass. You've likely already used a stirring hot plate. A magnetic stir bar is placed in the flask so a reaction can be heated and stirred simultaneously. The type of stir bar depends on the flask. Oval or football-shaped bars are best for round-bottom flasks. Use rod-shaped stir bars for flat-bottomed glass. If you want to heat a round-bottom flask on a flat hot plate, use a water bath. If cooling is desired, an ice bath is used. Water should be added to the ice bath to ensure heat is distributed evenly. For temperatures below 0 degrees Celsius, salt may be added to the ice bath. The reaction flask should always be clamped above a stir plate, even if it has a flat bottom, and especially if it's resting in a bath. If stirring isn't needed, a heating mantle may be used. Heating mantles pose a fire risk if plugged directly into an outlet. They must always be routed through a variac or voltage regulator first. If a flask is too small for the mantle, sand may be added. Heat is then adjusted on the variac. A condenser is composed of two concentric glass tubes. The outer tube is connected to some flanges and cold water is run through it. This keeps the interior tube cold, and any warm vapor that contacts it condenses back into a liquid. After clamping the condenser to a support stand, check your rubber tubes for any damage, then attach them to the flanges. The lower tube should connect to the water source, and the upper tube should lead into a drain. Slowly turn the water on and watch it fill the condenser. The water entering the drain should be left at a light trickle. Condensers pose a flood risk if the tubes are damaged or not attached securely. Protect tubes from melting by using the clamps to hang them away from any heat sources. Condensers are used in reflux setups, where solvent vapors condense into liquid and fall back into the reaction flask. This allows the reaction to stir at a constant heat of the solvent's boiling temperature. Condensers are also prominent in distillation setups, where vapor of one component is condensed and separated from the rest of the mixture. When finished with the condenser, remember to turn the water off. With the condenser still clamped, disconnect the tube from the water source and immediately point it into a drain. Air pressure should empty the condenser, but you may have to lift up a tube if water is trapped inside. Now the condenser can be removed from the clamp or left for the next user. With a grasp of these fundamental pieces of equipment and a little creativity, any reaction setup is within reach.